Okay, so basically in Nyquist, what we have said, we have the characteristic equation. Okay. We would like to determine from Nyquist how many zeros of the characteristic equation will be on the right half plane. So if I have a system, this is the feedback system, G of S, okay, H of S, this is R and this is Y. So Y over R equal to what?
G over 1 plus TH.
G over 1 plus H of S, G of S. Okay, where this is the
Characteristic equation.
Characteristic equation. Okay. العرفج. Okay. What is the relationship between the zeros of the characteristic equation and the pole of the closed loop system? العرفج, are you with us?
Yes, yes.
Ahmed?
Yes, I think it's the same.
قرب المايك احمد, ما بسمعك. What is the relationship between the poles of the closed loop system and the zeros of the characteristic equation?
The same.
They are the same. Great. Thank you. Okay, now, so let me also suppose the open loop system, which is, G of S, H of S. This is the open loop system. Let me put them as in numerator and denominator. Suppose they are given in terms of numerator and denominator. So the characteristic equation, F of S equal 1 plus N of S D of S, which is equal to D of S, okay, N of S plus D of S. Okay, now, what is the relationship between the, okay, what are the pole of the characteristic equation? Okay, what are the pole of the characteristic equation?
They are the poles of the open loop gain.
Exactly. And then, so pole of F of S are the poles of G of S, H of S. Zeros, so this is open loop. Zeros of F of S are the poles of the closed loop system. In Nyquist, what we want to do, the first thing we will do, we take the S-plane. And this is the real sigma, this is J omega, and we take a contour. The contour is the entire right half plane. So I will start from 0, go to infinity, all the way, take the entire plane and come from the negative side. And in this one, I will locate the poles of the characteristic equation, which are, let's say, I have some poles here, which are the pole of the open loop system. So P immediately is given, P is given, P inside the contour, the F of S contour, which is this one, are given from open loop system. Okay, this is the first step. Step 2, you plot the f of s plane, and you get, let's say, this is the -1, and this is, you get n from here. So if you find n, then z, the zeros of the characteristic equation equal to n plus p, where z are the number of zeros of the characteristic equation in this area. So if z equal to 0, the system is stable. Otherwise, the system is unstable. This is basically what we want to do. Any question here?
So, Doctor, the B is the poles of the characteristic equation. N is the zeros
Circlement of the -1 in the f of s plane.
circumference of -1 in the S plane. F of
Exactly.
S plane. Yes.
Okay.
In the F of S plane.
In the f of s plane, yes.
Yes, yes. And how to determine the number of encirclements?
We will, after we graph, after we map this one into here,
I see.
each point, I will get a point here. So after I will go over the entire the f of s plane, I mean entire the Nyquist contour, okay, I will get the encirclement.
Yes, exactly.
And
So if
then,
we don't have any point in the right half plane, so the number of encirclements intuitively will be 0.
if the system is stable.
Exactly, because there will be
If
nothing
the
in
system
the
is stable, because you
right
want
half, yes.
n plus p equal to 0.
I see, I see, I see.
Any questions about? If there is no question, let's take an example. We are going to have several examples. Okay, suppose I have the system and I would like to investigate the stability of the system. The first thing we will do, we will take the S plane. This is S plane. This is sigma j omega. And let me locate on the S plane the poles and the zeros of the open loop system. I have one pole. Where is the location of the pole?
It's at -1.
-1. So it will be -1. And let me take my contour, Nyquist contour. The Nyquist contour, we said, I'll start from 0, go all the way to infinity, take the entire right half plane, come back. Okay, this is my contour. Inside the contour, how many poles I have?
Nothing.
What?
Yes, nothing.
We have nothing, yes.
We have no pole of the open loop system and no pole, which means no pole of the characteristic equation in the right half plane. Any question here? Okay, so what I want to do, if I go through this contour, I would like to get the f of s plane. How do I behave? How does the system behave? Where is the mapping? This is real, this is imaginary. But let me write my open loop system in the frequency domain. Replace s by 1 over j omega plus 1. J omega, sorry. So it's going to be, the transfer function is going to be 1 over j omega plus 1. What will be the magnitude?
1 over omega squared plus 1 under the root.
Angle, phase.
minus tan inverse omega.
Okay. So let me select this point. Let me start with this point.
Yes.
This corresponds to omega equal to 0. So G of 0, J0 equal to
1 in the magnitude and 0 in the angle. So it is in the real.
wait, Abdurrahman. Abdul Latif, Ibrahim. No, Abdul Rauf, I think. Ibrahim.
Yes, doctor.
Okay, where do I locate this point? Where is it going to be in the f of s plane? 1 and angle 0. This is the 0. Okay, this is 0. This is 90. This is 180. And this is 270 or 90 or minus 90. Sorry. So where do I position this point? Where is this point in the graph? In the plane. Sorry. Where do I put it?
180?
Where?
At 180?
No, it is okay. This is 1 with angle of 0. Where do I position it in this coordinates?
In the x-axis, in 0.
The real axis,
This is
yes,
1.
on the
Yes,
real
yes.
axis. So it is going to be somewhere in here. Let's say this is minus 1. Sorry, this is 1. This is the point. 1 and angle 0. And this corresponds to omega equal to 0. Now I am moving in this direction. I'm increasing omega. Let me take the extreme case G of infinity. What will be the magnitude?
0 minus 90.
Minus 90. Okay. Wait. Let's have another Al-Isa. Ali Al-Isa. Al-Isa. Where is this point? Where is the 0 and minus 90?
At the origin.
At the origin, but from where? So this is the origin, but from minus 90. So basically, we are moving somehow in this direction. This is correspond to omega equal to infinity. Okay?
دكتور
Yes.
عندي سؤال بس.
تفضل.
الحين اذا كان عندي اس سكويرد حيكون عندي 2 باتس ولا ما له علاقه؟
كيف؟
اذا كانت الفانكشن فيها 2 بولز
اوكي.
حيكون عندي 2 باتس ولا ما له علاقه؟
No, one. We will come. Look, if you hold on, in the next example, we'll have 2 poles. No, it will
Okay.
just look. You have a transfer function. Just find the, the magnitude and the phase. Or look, sometimes if you don't like what I'm doing, do it in the multiply by the complex conjugate. So you'll have what? 1 minus j omega over 1 plus omega squared. And this will be what? 1 over 1 plus omega squared minus j omega over 1 plus omega squared. It will be the same. All what we are doing, we are simplifying. I'm using the polar because it's easier.
Yes, it is easier.
Okay.
بس باقي minus infinity صح دكتور؟
Exactly. Now I want to go. Now I went to infinity. I'm coming at this point. So my frequency is going to be in the negative. And we said in the negative, we'll take the mirror image. We don't do it. We just take the mirror image of it. So it's going to be like this. And this is now the minus 1. So what is n equal to? How many times I'm encircling the minus 1?
0.
0 times. So z equal n plus p, which is equal to 0, which means
طيب في فكرة يا دكتور، إذا هي موضوع زي كذا فحنا يعني without going to the graphs we will just see how many times the magnitude can be -1
How many times magnitude would be
or less than -1
okay.
because it has two. يعني maybe this is a theorem that I'm just now stating. I don't know.
Great والله. أقول عبد الرحمن great, please why don't you put your idea. والله ليش لا يعني we will try بس anyway. So look this
معليش دكتور، بس ال n plus b ما فهمته.
كيف؟
ال n plus b ليش 0؟
لأنه look إحنا هنا قلنا inside this contour how many poles I have?
0 balls.
0 pole. Now in this graph this is the -1 and this is my graph from 0 to infinity and from -infinity to 0. I am in this area. How many times I am going around the -1?
0.
0. So according to the theorem, the number of zeros of the characteristic equation in this area equal number of encirclement of the -1 plus number of the poles inside this area. On both of them, they are 0 plus 0, so it will be 0.
So we get the balls from the first plot and the zeros from the other plot.
No, the pole from the first plot and the encirclement from the second plot. N from the second plot.
Yeah, yes,
Z,
yes.
okay, Z will be the addition of the two.
Okay, okay, I see.
Any other questions?
معليش دكتور، بس n تمثل number of encirclements يعني؟
N number of encirclement of the -1.
Oh, okay. تمام، مرة دكتور،
Just
شكرا.
one second. Just one second. Let me. Okay. Basically, what we are saying.
I think دكتور الفكرة اللي طرحتها لك بس لو بكملها يعني we can
عبد الرحمن, honestly speaking, look, this is if you are talking about research problem, no. Now time is very pressing.
yes, but we can write a mathematical.
Look, أقول لك عبد الرحمن, after the class I will be more than happy to discuss it with you.
ممتاز.
Okay, by all means. حياك الله. This is great يعني I'm not بس المشكلة I have to يعني حقيقة الشباب الباقيين I don't want to slow them down.
تمام.
Okay, so look, this is the theorem, Cauchy theorem. The number of a feedback control system is stable if and only for any contour f of L. This is in the S plane. The number of counterclockwise encirclement of -1 point is equal to the number of poles with a positive real part. Okay, then, or what we are doing, we are taking it the other way around. Number of poles inside the Nyquist contour, and this is number of encirclement of the -1. You just find them, and that will give you how many zeros in the right half plane.
Yes, clear, doctor.
For example, okay, let me have the system. Now I have 2 poles. Okay, again, I would like to investigate the stability. So let me put the S plane. Okay, where are the location of the poles in this system? In this case, where do I get how many poles I have?
2 balls, 0 and -1.
0 and -1.
Yes.
Now let me take my Nyquist contour. Nyquist contour, we said we take the entire right half plane. So because I have a pole at the origin, I cannot start from the origin, because if I pass through the pole, the system, this is it is a singular point. The function is not analytic, so the theorem will not hold. So what I will do, I will modify my contour. I will start from 0 plus, go all the way to infinity. Okay, include the entire right half plane, come back to the negative. Okay, before 0, take a detour. So now, how many poles of the open loop system, which are the poles of the characteristic equation inside my contour?
0, 0.
Okay, so it's going to be P equal to 0. This is outside. Okay, now let me do the graph. So now already I have P. I need N now. For N, let me say this is the F of S plane. This is real, imaginary. Okay, let me
G omega, GH of
G
omega.
of J omega equal to 1 over J omega plus 1. So the magnitude is equal to, what will be the magnitude, Shabab? Wait, let me, just 1 second. Let me select one of you, can help. Ahmed Nakhli. Ahmed?
Yes, doctor.
What will be the magnitude? Can you tell me? I have two factors. What's the magnitude of the first one?
It's just the square of the denominator.
Okay, so basically, look, this one will give me, because there's no real part, so it's going to be just omega, and omega is positive. How about the second part?
It will be omega plus 1 square.
Exactly.
Omega square.
Thank you.
Yes.
Shabab, what about the angle? What will be the contribution of the J omega?
90. Contribution is 90.
So it will be, because it's denominator, so it will be minus 90 and minus tan inverse of omega. Okay. So now let me start by omega 0 plus. So G of J 0 plus. It means that I'm at this point, let me call it A. At point A, what will be the magnitude?
0 plus.
Okay. So what will be the
be
magnitude?
Infinity.
Infinity. The magnitude infinity. How about the angle?
Minus 90.
Minus 90 minus epsilon. Small number. Because I want to position this point. Where is this point?
I see.
So it's going to be, this point is going to be in here. The point, oh, okay. So this is correspond to omega equals 0 plus. Is it clear why it is here, not here? Because if, you know, omega is very small number, it's going to be very small number. But minus 90 minus that small number, which is going to be cross the minus 90. It will be in the third quadrant, not in the second quadrant.
Yes, clear, doctor.
Okay. Now, take G of J infinity. What's the magnitude?
0, and we have minus 180.
Okay, so basically, I will be going in this direction. Tangentially, I will approach the 0, but from this one, where this is correspond to omega equal to infinity.
دكتور
Yes.
بس انا عندي مشكله لما توصل بين التو بوينتس يعني ما اعرف كيف الباث تختاره بالضبط.
Look, if you have any problem, okay, اخذ اي نقطة in between. اختار اي نقطة in between. لنفرض suppose omega equal to 1. Let's take omega equal to 1. Okay, if omega equal to 1, what do we have? G of 1. This is equal to, magnitude equal to what? 1 over root 2, isn't it?
Yes.
What about the angle?
This is minus 90.
Minus 90.
Oh, yes. Minus 45.
So it's going to be somewhere in here, in the third quadrant, isn't it?
Yes.
Which means that you are moving in this direction. If you increase this, look, what we are graphing, very rough graph. It's not accurate. It is just the idea. It is how does it behave. At certain points, yes, we do later on when we talk about the phase margin, gain margin, and stability. Sometimes in certain cases, we need the intersection. We need more points. But now this is, very rough idea. Okay, you can take more.
Okay,
more
well,
points. Is this clear?
yes, it is clear, Doctor.
Okay, so now this is for the positive frequency. What will happen to the negative frequency?
It is the mirror.
It is the mirror image. So it's going to be, and this is correspond to omega equals 0 minus. Okay. Now I need to, how do I connect them? Okay, how do I connect them?
هذا سؤال صعب.
That
لا
I go to
ممكن يا
address.
دكتور ناخذ with respect to real the what is called the reflection. So it's kind of a symmetric
Yes.
way to do. Yeah. So
Yes.
yes.
Okay. Now, okay. Let me.
But I have a question, Doctor.
Tafadhal.
How did you know that you will go through this line that you have drawn here? Yani with this kind of curvature, you know what I mean? How did you know exactly that you will have this kind of curvature?
You don't have it exactly. It's rough. Similarly, yeah, look, root locus, do we sketch them exactly? We don't. But
I see.
the j omega axis, the breakaway point, we know those. But now it doesn't matter to me. I will come in certain places. It is very important. That's basically in here. This is the -1. So it's not important to me. Later on, in certain problems, no, it is very important to know where do I intersect the axis. Where do I have, in certain cases, like this, let's say I have, it's very important to me, what is this intersection? Is the
Yes.
or in here?
This will be resolved when I state my theorem, inshallah, at the end of the class.
Right? Okay, so now let me we try to work on the connection between what I want to do now. I want to go from this point to this point around the around the circle. This is half a circle. Okay, so let me in this area assume S equal to rho e to the j theta. This is an equation of a circle. Okay, and let me around this area, let me substitute for S in here. So G, rather than j omega, we will say rho e to the j theta. So what do we have now? I will have 1 over, just substitute for S, rho e to the j theta and rho e to the j theta plus 1. This is approximately equal to what? Can I approximate in here? Look at this term. This is 1 and this is rho. What do you think?
Oh, is what, Doctor?
We can ignore this term. So basically, this is going to be 1 over rho e to the j theta, which equal to 1 over rho the angle will be minus theta. So in this area, I'm doing the approximation.
دكتور,
Yes.
what does rho represent?
Rho is very small number. Epsilon, like epsilon. Rho is very small. Radius, and look, this is circle of radius rho, and rho is approaching 0.
معلش دكتور, بس أنا I didn't get the idea of e to the power j theta. What is, why we use e to the power j theta and e?
This is a circle, equation of a circle.
Yes, it is. I see. Equation of the circle.
Yes. I'm moving around along this line. Okay. So now let me make theta and in this area, the phase of g of s, which is equal to minus theta. Now let me suppose I'm at this point at omega equals 0 minus. What will be theta? If this is my reference, this is the 0 line, what will be this? What is the value of theta in here?
Minus 9.
Minus 90. So if theta is minus 90, what will be this g of s? What will be the phase of that? What will be the angle in here? Substitute in here minus 90, it will be 90. And of course, in terms of magnitude, is at infinity. So where is this point? This point, call it J. This is get mapped to this point in here, to the 0 minus. I'm mapping this point to this point.
ليش دكتور؟
Look, this is, okay, in terms of the magnitude, okay, the magnitude 1 over rho. Rho is very small number, so the magnitude will be at infinity, isn't it?
Yes.
Okay, now, this angle is minus 90. And if you substitute in here, what do you get?
90.
90. Where is the 90? The 90 here. Okay?
دكتور, بس معليش الحين الاس equal e multiplied by e to the power j theta, صح؟
Yes.
بس ليش عوضنا بالاس؟ الاس المفترض انها just the g omega يعني.
ليش عوضنا ايش؟
ليش عوضنا ب e multiplied by e to the power j theta? This is Euler.
I would like, as I said, this is a circle, an equation of a circle. And I would like to avoid this area. I would like to avoid going through the, you know, the singularity. I cannot go through the singularity. So the best way for me to move from this point to this point is on a semicircle, or on a circle, half a circle, sorry. And the equation of the circle, this is the equation of the circle.
طب دكتور, minus 90 كيف جبتها ثيتا؟
ما نحتاج ايش؟
لا, minus 90 ثيتا, هذه ما فهمت
Okay.
كيف جت.
Look, if I will use in this area around the origin, let S equal to rho e to the j theta. Okay, so if you
Okay.
substitute, you get, this is basically, you get the magnitude and this is the phase. Okay,
اي هذه واضحة دكتور.
كيف؟
This is good, بس قصدي how did you get minus 90 degrees?
Okay, now tell me what is the coordinate of this point. Let me, I'm at the point J. How do you read J? In terms of the magnitude and in terms of the phase. The magnitude, we said it is rho. It is the, you know, okay. What is the angle? Shabab, look, this is in the polar plot. This is 0. This is minus 90. This is minus 180. This is minus 270. Or this is 90. This is 180. And this is 270. I am at this point. What is the coordinate of this point in terms of the magnitude and in terms of the angle?
Infinity and minus 90.
Exactly. Rho. No.
It's here. It is 0 degrees.
Okay. Rho and the angle will be minus 90. I'm substituting now. So substitute for the minus 90. It will be substitute in here.
Yeah, now I get it.
Okay. So now, if I am at minus 90, okay, the angle will be 90, which is here. Suppose I move along this direction and I reach in the middle. What will be the angle? Halfway.
Minus 45.
Minus 45. What will be theta of the phase of the system?
45.
45. Okay, so this means that I am moving in this direction. The 45 in here and at infinity, magnitude at infinity. Now, let me reach this point. What will be the angle?
0.
0. This will be 0. So I'm moving here. Okay. Then at 45, because I reach here, so at 45, this will be minus 45. And finally, at 90, if I reach this point, A will be 90. And this is going to be minus 90. So basically, I'm closing the thing in this direction, in this one. And this is the minus 1. So what is n equal to? How many times I'm encircling the minus 1?
0.
0. Z equal to 0 plus 0, which is equal to 0.
Doctor, here we are circling the pole at 0.
We are excluding the pole at 0. I'm moving in this path. You might ask, what will happen if I change the path? What I'm saying, let me take the other case. Suppose I have, this is my pole, this is the other pole, and let me take the contour in this way. Okay, so what's P in this case? This is S plane. What's P?
Also 0.
Huh?
0.
No,
It's 1. It's 1.
I'm including it. It's equal to 1.
Oh, yeah.
Now let's go in here.
So we have to take the both cases, Doctor.
Look, the first of all, this is what we have before. We don't have any problem in here. This is the omega equal to 0 plus.
Yes.
This is, okay, omega equal 0 minus. Now, let's take, again, we have, if S equal to rho e to the j theta, we said we are going to have G of
دكتور الرو زي الاي ترى.
rho is, كيف؟
انا قاعد في السلايد الرو هذه زي الاي يعني، فانا قاعد في السلايد اللي قبل اقول ليش الدكتور قاعد يضرب في اي.
Okay. Well, look, so this is G of rho e to the j theta. فعلا my rho and e almost the same.
عشان كذا انا قاعد احسب قاعد ملخبط يعني ليش هذه why is this is here.
So this is approximately, we said, if you remember, from the rho e to the j theta, which is equal to 1 over rho angle of minus theta. This is what we have. Okay, let's
Doctor, here, how did we approximate this? We
Wait, what?
approximate this.
because Okay, look, you have rho e to the j theta for this term, and this term rho e to the j theta plus 1. But we said rho is very small number compared to the 1, so I ignore it. Okay?
Okay.
Approximately, this is what we have.
Clear.
Okay, now, this is theta, this is, okay, minus theta. Okay, I am at this point. We said this point corresponds to this point. At minus 90, this will be 90. Suppose I'm at this point. What is this point? What is the coordinate of this point now? What is the coordinate of this point?
minus 135.
Minus 135. So this will be where? What is this is going to be?
Plus
The second column.
35. If I am here at this point, what does this point correspond to?
So
Minus
180.
Minus 180.
yes.
And this is 180. So look, now I'm moving in this direction.
Clockwise.
Okay. And then if I'm 135, sorry, no, minus 2 to, since I'm going in the, so it's going to be
Minus more than 180.
minus 225. This will be 225. And finally, if I will be at the
minus 270.
minus 270, this will be 270. So basically, this is the path which I'm going to have. And this is the minus 1. Because this is
How did you know, Doctor, minus 1 is inside, not outside?
exactly. So what's n equal to?
No, how did you know that?
How do I know what?
The minus 1 is inside, inscribed.
Yeah, Abdurrahman. Yeah, Abdurrahman. We are saying in here, we are at 1 over rho. And rho is very small number. What's the magnitude?
The magnitude of 1 over rho,
Yes.
it's almost infinity. Yeah.
It means that this is, we are moving
Yes,
toward
yes.
the infinity
Yes.
line.
Now I got you. Yes.
Okay. Now, what will be n equal to? Shabab, yalla, quickly.
One.
1. No. It's counterclockwise now.
Oh, yes.
And z equal to minus 1 plus 1, which is equal to 0. So it doesn't, what I'm trying to say in here, it doesn't matter which path you will go, in this way or the other way.
I think the best is to exclude the ball.
No, what I'm trying to, I mean, we want to show that it is independent, it's irrelevant, the path is irrelevant. Okay?